let's look at the West Mock 2024 physics questions, and the question that caught my attention was question 2. So basically I'm just going about picking random questions and trying to create their PowerPoint presentations, and then creating the video solutions later and uploading to YouTube, so that you actually see the process that I undergo before coming out with a video. I uploaded a video, I think yesterday. I uploaded a video yesterday, and that video I used 1 hour 23 minutes to prepare the video. Then I spoke, that is, I used 1 hour 23 minutes just to prepare the video before even doing the video. Now I just came and I did the video solution of what I was preparing just for 30 minutes. So you see that at the end of the day I used almost 2 hours to work on a video. It's not really easy, but it is worth, because at least I receive good comments, encouragement, the subscribers are increasing, the likes are increasing, the shares are also increasing, the algorithm is favoring the channel. So I just have to continue doing that, because I know that at least it is also helping you guys. So this video that I'm doing now is specifically for teachers that also want to get involved in using PowerPoint to prepare their videos. I basically learned everything by myself without any help of YouTube videos to see what to do, and I know the process I went through to learn everything by myself. It was not really easy. So basically whenever I'm faced with a difficulty, I get to solve the difficulty by myself. I've never come to YouTube to search for a video, but it is very, very difficult to do that. It requires a lot of time, and if you're not dedicated, you will give up. So if you're watching this video and you're a teacher, then I can say you're very lucky. Yes, you're very lucky, and if you follow my steps, then everything is going to be good. So there are so many questions in this paper, but I'm going to select just the question that has diagrams. All right, because a question without diagram is not really. I want to do a question that has a combination of text and diagrams. So question 2 is better. So this is what I do. I have to take everything to my PowerPoint software. So this is a question that I want to copy into my PowerPoint. So I'll just copy the question, I'll just crop the question and carry it to PowerPoint, so that I'll just be typing the question there directly. So this is my PowerPoint software. My best template is always this dark template. Anything that has to do with a dark color, because the white color, the intensity there is too much and it disturbs my eyes. Okay, so this is what I copied, so I just have to paste. I could just prepare my solution directly already. Okay, that is in case I don't have time. I could just copy and paste the question, then I prepare my solution. But no, I will want us to replicate this, to produce it back. I'll not do so many things, because it's too stressful to do this. Okay, so first of all, we started by setting up our slide. There is no need to set up a slide again. I have many slides that I've set up. So I'll basically, for those of you who have watched this video, I'll just basically copy this setup here and just carry it to that. If you don't know how I did to set up this slide, then you have to go and watch how I prepared this video. You see how I set up this slide. Alright, so this is it. I think some things are also lacking. Some vertical lines have to be included. This line here, and this line have to be included. Alright, so I'm done setting up my slide. Now I need to copy this question. You see, just by setting up, you see how things are presentable. If, for example, if I did not set it up, it's very bizarre, right? Like maybe let me just copy and paste and delete everything here. You see the way the slide looks, but look at the way this slide looks. It's more presentable. So this thing involves a lot of creativity, a lot for you to be able to conceive ideas to design your slide this way. It's not easy. So when I just see guys coming out there and just doing what they want, I'm just like, okay, a ball is kicked. Like I explained, you must, before you start writing, you don't just write on the surface. You must insert a text box. So you take the text box and draw, then start writing inside. That is what I did. So a ball is kicked from horizontal ground towards a vertical wall. A ball is kicked from the horizontal ground towards a vertical wall. Let's give this font size 24. As shown in figure 1 below. So you are going to draw the figure, okay, but for now we'll just keep that figure for now. Let's first of all finish with the question. Okay, now I think the figure can enter here, so I'll just continue. Then here it says the horizontal distance between the initial position of the ball and the base of the wall is 24 meters. Now the ball is kicked with an initial velocity v at an angle of 28 degrees to the horizontal ground. Now the ball hits the top of the wall after a time of 1.5 seconds. Air resistance is negligible. This air resistance negligible, just to tell you that the acceleration in a vertical direction is the acceleration due to gravity. Now question A, I think I need to shift this one so that I have space. Question A, calculate the initial component Vx of the initial horizontal component Vx of the velocity. Question B, calculate the time taken for the ball to reach its maximum height above the ground. And option question C, calculate the maximum height above the ground. Okay, so I kind of, there's a wrong spelling of calculate here, so I'll just autocorrect, shift this man up, add end to ground. Okay, now I think all we are now left to do is to draw the diagram, right? So let us draw this diagram. So I'll just put everything down here, then I draw the diagram. Okay, so we have the horizontal, I don't know why, in fact let me shift this man down, I put the diagram here and draw. Or in fact we are done with that, so we can just crop and just allow the diagram. So you could just, I don't know, maybe if the diagram is too difficult for you to draw, you can just crop the diagram and you insert it into your into your PowerPoint presentation. Yes, but I don't like this. I prefer to draw my diagram so that in case I want to use it, I'll use it. So we have the horizontal ground first of all. So I draw a horizontal line. Try to decrease the length of the line. Then next I give it 3 here. I make it to be purely white. Now next is the ball. Okay, the ball. Here's my ball here. I take no fill. I take the white coloration, then I increase the thickness, the outline. Okay, I can even change the outline color to indicate that that is the ball. Next thing is the wall. The wall is somewhere here, right? Here's my wall. Now we take fill, texture. If I give it this, it doesn't make sense. Now let me just put it here and try to adjust it first. Texture. I think this man is representing a wall, right? Okay, keep it there. The outline, if I take no outline, it makes sense. This is actually a wall. Okay, let me see if it shows clearly that it's a wall. Voila, it shows clearly that it's a wall. Next, what do I need to do? The surface of the ground, these horizontal lines, these slanted lines down here like that, that's so much work to do. I'm not going to do that. Now we need to indicate the projectile, the speed. So something like this, kind of increase it, the width of the thickness as well, and give it a white coloration. Let me see. Okay, now maybe decrease. Now the next thing to do is, okay, now we need to indicate the trajectory. So we just need to take an arc, and then now we form the arc to resemble what we want. So it begins normally like this, and then I don't know if this is supposed to be increase the width first of all before we give it the dashes. Voila, something like this. Indicate that it's for the ball. I can bring this man now closer, and I decrease. Voila. So something like this. Okay. Now the next thing to do is we indicate that that is V. Here is V. Take it to 24. Here is V. Then some other indications: the path of the ball, path of the ball, path of the ball, path of the ball. Decrease the font size, at least it's a diagram. Then take, indicate that as a part of the ball. Increase the weight a little bit and give it a white coloration. Then the next one is the wall itself. I'll specify that vertical wall. And the next horizontal ground. There's a horizontal ground. I think it's too long, so kind of decrease, put the horizontal ground here. Now we need to indicate some distances, so I have a little vertical line here, copy and paste and place it here again. Make it to be, increase the width first of all, increase the width as well, then I make it to be, well, yeah, like this. Then give it a white coloration, then indicate that distance, that distance is 24 centimeters, pardon, 24 meters. So that distance there is 24 meters. Carry and place it there. Then the next thing to do is to indicate the angle made by the velocity with the horizontal. We take an arc, okay, we bring it closer to the velocity, we make it, let it, so I think something like that is good. Then we talk about 28 degrees. It is too big, so I have to decrease the size. It's not the equation, it's on the diagram, so decrease the size. Now we have to also indicate the ball itself. We have to indicate the ball. So we have to indicate that is a ball. Okay, and we are good to go. How is this? As easy as that. So there is no room for I don't know how to use it, it is difficult to do, it is that. Please, I'm really pleasing because of what I've been seeing recently. Okay, all right, so I think I'm done with this diagram, right? This 24 is too up, so I'll try to increase this man also, then shift this man to be down. At least it now makes sense. Try to decrease a little bit. Voila. This man like this, I better give it should better look like this, white. Yes, 24 meters. So I think that is all. Is there any other thing I need to indicate here? No, everything is set. So I just delete this and I bring back this man up here. I can even try to centralize it. I must not draw it the way it is exactly on the diagram. So I copy everything, and I try to centralize it. Okay, that's my figure. And I carry this man and I place. So with that, I'm basically done with. I want to shift it a little bit upwards. So I'm just selecting everything so that I can shift upward. In fact, I can just copy everything like this now. Yeah, and shift. Voila. If I shift upward a little bit like this, so at least I shift this man here. So I'm basically done with my diagram, okay, and with my equation. Now the next thing is I need to start solving. So I will duplicate this very slide. Let me delete this slide that was not. I'll duplicate this very slide. Then I basically have to, I need to start with the first question so I can delete this question here. Okay, I can delete this question. This other information was already given in the question, so if I don't want to delete it, I can come back here, copy back everything, and then I send it to the left. Okay, send it to the left, then copy this information here out of this, then I put it around here. I don't know, we'll put it around here. Okay, put it around here just in case, just for putting sake. If I put 20, yeah, it's not bad. 20 is not bad. 24, it's going to take space, so 20 is okay. So I can now put maybe a divider. I can put a line here to divide. Okay, this is the question, this is information that is just describing what is on the left. Oh, I went and selected an arrow. I'll just copy this one and paste, then bring it here, then increase the length. Okay, then now I could also just kind of, I don't know, well, I'm just trying to put this man in a box. Not really necessary, let's just allow it like this. Okay, yeah, I think with this we are good to go. And I'll bring this first question here, then I start solving. Okay, I start solving. Calculate the initial component of the initial horizontal component of the velocity. Let me see. So we go back to the diagram, okay, and then we indicate the vertical and the horizontal components of that velocity. So I come to my diagram, I indicate my vertical components of the velocity. I can give it this man, then I increase the weight as well. Then I also indicate the horizontal components of that velocity. Okay, I give it this man, then I also increase the weight. Shows that I have to, so I have to also make this man to also be thick. Okay, now I can just write their values. Okay, this man is Vx, this man is Vx, this is Vx, and the other man is Vy, the initial velocity in the vertical direction, Vy. Okay, in fact, I'll change this V to U. Yeah, I'll change it to U, so that I'll be using V as final and U as initial. So I can change the equation. I will not be beaten for that. So I just have to use U, so that at least I'll be using, if there is need, if I need to use V, I'll use V for final velocity and then U for initial. I don't want to be using small v and capital V. Okay, so I think, is there any U here? So yeah, I'll just put the U here, correct everything. Okay, so how do I approach this? Let's see. So we have the distance it covers, yes, and it's horizontal distance. So I use the fact that S is equal to UT plus half AT squared. I use this knowledge. Then with this knowledge, it means that the horizontal distance Sx will be equal to UXT plus half AXT squared. And if you learn that when I'm doing my video, I'll explain to the students that my Tx and Ty are the same, so I just call it T. And since in the horizontal there is no acceleration, this becomes 0, and we just have Sx is equal to Ux. Okay, now it therefore means that 24 is equal to ux times the time taken to travel 24 meters horizontally according to the equation here is 1.5 seconds. So times 1.5 times 1.5. Okay, so this means that my ux, which I'm looking for, is equal to 24 divided by 1.5. 24 divided by 1.5, 16. 24 times 2 divided by 3, 16. Okay, so that ux is equal to 16 meters per second, just putting it in units. Okay, so I'm done with ux. Now let's go to question B. Calculate the time taken. So I think the solution of this question will just enter into, I think it's just going to enter this one slide. You see, just going to enter one slide, and I think it's going to take it's going to be maximum and maybe like maximum 5 or 7 minutes to explain the solution, and you are done with your video, and it is very presentable. So dear teachers, just bringing this so that at least we should improve in our video quality. Calculate the time taken for it to reach a maximum height. Okay, so in fact there's much space here. I don't know, calculate. So I must not use this very equation. Calculate the initial. So I can just say calculate. So the first question I can just say finding ux. Yes, finding ux. The second question, finding t to reach h max. That is it. Okay, so I think anyways if we place it here, no problem. There's no problem. So if that's the case, then I will need to increase the font sizes. At least the font size should go back to 24, so that at least, but the last question, is it long? No, it's not long. So 24, so I begin from here, 24, place it here, 24, place it here, 24, place it here, then 24, place it here, then 24, and in fact it means this, it means this, then it means this. Place it here, carry this man, finding h max, finding time to arrive h max, bring this line here and place here and increase the length of the line. Okay, so finding h max is the next objective. Can put the equation in this color so that I should distinguish the equation from the solution. Finding time to arrive h max, so I can come to my diagram and then I indicate that okay, this is maybe h max, that's the point of h max. Okay, can I give it red and also give it a red filling color? Does it make sense when we play? It makes a little bit of sense. It's not really making sense. Well, I think this man is going to be perfect. So that's H max. That is the indication of H max. So I need to calculate the time taken to arrive H max. That's what I need to calculate. This projector has to touch this man here, and I wonder it should be a little bit longer. So I have to decrease a little bit and place it here. Anyways, so I indicate that this is H max, and then I'll indicate a distance. That is vertical distance here is H max. Okay, that vertical distance there is H max. Maximum height above the ground. And then at H max, your vertical velocity is 0. So we have to say that at H max, we have that the final velocity in the vertical direction is 0. So with that, what do we have? So it implies that what's that final velocity in the vertical? uy plus ay times t is equal to 0. But before doing that, I'll need to talk about what that equation of motion that says that v is equal to u plus at. Talk about this man. Okay, so I don't know where I'm going to keep it. I'll keep it somewhere. That will guide. I will put it in bold and then can give it this coloration. So I'll just put it here. Yeah, I'll just put it there. So since we are since air resistance was negligible, then your A will be minus G because you are moving against gravity. So this means that since you need to find the time taken, that time taken will be equal to uy divided by G. That's the time taken. Okay, so what is uy? Uy is actually the initial component of the velocity in the vertical direction. So it is u sine 28 degrees. That is uy. Okay, where u is that initial speed. So uy is equal to u sine 28 degrees. Now knowing fully well that my ux is equal to u cos 28 degrees. Okay, it therefore means that my ux I had was 16 is equal to u cos 28 degrees. So I kind of maybe just put where uy is equal to this. I'll just put it here. Now ux is equal to this implies that ux is equal to, implies that 16 is equal to that. So this therefore means that my u is equal to 16 divided by cos 28 degrees, which means that my uy will be equal to, I need to take this u here, then I divide it by g. So this is u. Okay, no, my u, wait, no, is u sine 28. So we need to take this u, then we multiply it with sine 28. Multiply with sine 28 degrees. That is uy. So at the end of the day, I think it is clear that uy is equal to 16 tan 28 degrees. Our alarm answer in terms of tan, you punch. So uy is equal to 16 tan 28 degrees. Just hope I've not made an error somewhere. Okay, so it therefore means that my t will be equal to 16 tan 28 degrees divided by g. Either I use g as 9.8 or g as 10, it depends on you. Okay, I'll just allow my answer like that. Alright, I think we are done with that for now. Now we have the last part of the question, which is saying calculate the maximum height. So in the last part, we are finding h max. So C, finding h max. I hope it enters. Perfect, it has entered. So I think it is preferable to fill up this gap down here by just doing this, shifting by shifting everything to the bottom. So I shift everything to the bottom, I pick and pick and pick, and I place here, right? It makes sense. Then now with this guy here, I can talk about, but I'll try to fill up this space later on. So what is h max? I think this thing has taking so much space. So for me to economize space, I could do this. S is equal to this. It means that Sx is equal to this, which means this, which means this, and eventually means this. Then I can, I don't know, shift everything here to the left, so that I should have some space there to calculate h max. The space should not be negligible. So finding h max, if I bold it, how will it look like? If I bold, will there be space to expand? Yes, there is. If I bold, okay. Alright, now what do we need to do next? We need to find h max. So I'll say use the fact that sy is equal to uyt plus half a ayt squared. So I think if I do this, if I say s is equal to this, I can just put a note here of sy, because if I put it here, anyways, if I put it here, I don't know if there will be space for me to proceed. Let's just see. So this means that this means that my h max, I'll just call it h, is equal to we have found the time to arrive h max t. Okay, do we have uy? Yes, we have uy is u sine 28 degrees. What is u? U is 16 over cos 28 degrees. So uy will just be, we found uy even already. Yeah, we found uy already. So uy is 16 tan 28 degrees. So I think we just have to talk about, okay, we have uy to be equal to, we have uy to be equal to 16 tan 28 degrees. Then we have the time to arrive that to be the time to arrive that to be 16 tan 28 divided by g. Yes, so we have the time to be 16 tan 28 divided by g. And what else do we have? We have that the acceleration at maximum height is minus g. We have that the acceleration ay is equal to minus g. So now all we now need to do is to substitute. Okay, and then we get the maximum height. Voila. So with this, basically we are done with the first part of the preparation of the video. So I can call this info. Okay, now what should this space, what should be written? Oh, so I went and wrote Midland here. I have to cancel, so it should be there. West Regional Mock Examination. So I have to copy, then I put here 0780 for physics. 0780. There is paper 2. 0780 physics paper 2. Okay, I was corrected yesterday that telephone is just 1L. Okay, now I have to copy this and copy and also copy, and I come here and I delete and paste, and I adjust this. Okay, so I think now I was saying that below now here, what do we need to write? Do you have anything special to write here? Because this space like this has to be taken care of. That space has to be taken care of. So I'll just insert a line there. Think about what we are going to write there. Let's see. Can I just write but I'll just write subscribe. I don't have anything in mind for now, so I'll just write subscribe, like, share. if I give it area black, does it make sense? Yes, it does make sense. So subscribe, like and share. I talk about comment as well. Subscribe, like and share, then comment. Okay, so we are done with the first part of the question. That is actually, what am I saying? We are done with the first part of the presentation. So we are done with the first part of the presentation. So now we have to, I adjusted this diagram here, so we have to adjust some other things. Now you have to animate. Okay, you have to undergo the animation process. Okay, so first of all, the first slide will come out unanimated. Second slide will be animated. So I will start with this question will not be animated. Okay, so I'll start animation from here. S is equal to ut plus half at squared, because I need to find that. Now I need sx this, then I'll now go to my diagram, then I'll indicate. I'll first of all animate these guys first, then I take start on click, then I'll go to my diagram and see that the vertical is UI, horizontal UX. Then from there I talk about this man and this. Okay, B at H max, finding H max. So I'll talk about this, then I come here and indicate that okay, this is the H max, this is H max here. At H max, Vy is equal to 0, but this is V. Oh, a mistake. Talk about this. Oh, in fact, I just allow that one. Talk about this. Second question, finding H max point, this and this. Let me see if I take splits. Alright, now at H max, this happens, V is this, so this happens, so this happens, this happens, where this is this. Now this means this, this means this, this means this, this and this, and then finding the H max, you just have to introduce this information. I think we can take wipe here. I don't know if it's going to be good. Alright, now if we play first slide, let's give a transition to the first slide. Transition, reveal, switch, gallery, flip. No, this is not benzene. No. Ferris wheel. Alright, nice. Second guy, let me try more fancy something. Perfect. Okay, now if I play, that is it. Now going to the next slide, I have this, then I just start my explanation. I just start explaining quietly, and in no time I'm done with the explanation already. So this video is too short.